Okay, if you understood the last video, well done. Not easy by a long chalk, but I did say that at the start of the video that we didn't necessarily need to use the for. We could have used the while loop. We just knew or we should have known that we were having a loop because we were going to do the same thing on each character of a string. So I'm going to use a while loop this time. Now the reason I used a for loop was because if anything has a finite length, the for loop is best to use, but we need to think what is happening here. So let's come down to here. If I entered a string like this, 0010 A, that would be perfect for a for loop because we would check each and every character. That's binary, that's binary, that's binary, that's binary. Oops, that's not binary. And the idea of a for loop is it does every character in the string, so it would do each and every one of them. So it would do 1, 2, 3, 4, 5 comparisons before it found something that made it fail. However, if I gave it this string, A1010, where the failed element is the very first one, it would still do 5 comparisons. It would do every single character in that string. So it would look at that, fail. Then it would look at that and just ignore it, ignore it, ignore it, ignore it. But it's just done 5 comparisons. Now, 5 isn't going to be particularly hindering to our program, but if we've got a really, really long string, maybe 1,000 characters long, not saying that we would have, it's going to do 1,000 checks even if the very first one made it fail. The beauty of a while loop is that the while loop will only will fail as soon as it sees the characters. So it will do 1 comparison in this one, 2, 3, 4, 5, exactly the same as the for loop, but if we had this string, 1, fail, it wouldn't even bother with the rest of them. So the while loop is a little bit more efficient than the for loop. So let's have a look at it. The only major problem is the while loop is a little bit it's more difficult to set up. We don't have this beautiful statement of saying for each character in the string. We've got to do that in a sort of programming sense using index notation. So let's take a look at it. One of the things that we need to know, we've got to be very careful because the while loop will just keep reading until it finds an error, but it has the ability to go past the end of the string, and if it goes past the end of the string we will get an error. So we've got to know how long our string is and check that it doesn't go past, because we're not, as in the for loop, which is automatically controlling that and it knows when it gets to the end of the string. The while loop has no idea where the end of the string is, so we've got to manage that. So we probably need another flag here, end of string, to help us know when we've reached the end of the string, and again that is going to be a Boolean value. So that's the first thing. We're going to have a bit of a difference in the loop. Let me explain what we're going to do. I'll finish this off in a minute with what we need to put in there, because the loop is while valid. Okay, so we're checking while it's valid. Okay, so if it's a 1 or a 0, we're going to move on to the next character, next character, next character. We're going to stop when it becomes invalid. So while valid and not the end of string. So that sort of reads English or makes some sort of sense. So if we do this with a string 0011, what this is saying, loop while it's valid. So if valid is set to true, we look at that, yep, that's valid. It's a 0, it's binary, that's valid, it's a binary, that's valid, it's a binary, that's valid, it's a binary, and I've reached the end of the string. So it's only going to look while it's not the end of the string. It's reached the end of the string, it's going to drop out the loop, and it's going to say that, well, that was all valid. If we have one which says this, so it's going to go valid, yeah, keep looping, oh, invalid, that's it. We're going to set valid to false, and it's going to drop out of the loop. Both of these things, because we've used and, both of these things need to be true. So it needs to be valid and not the end of the string. So end of string needs to be false. So we can set false to begin with for it to enter the loop. Okay, so it's valid, true, okay, and that is set to false. The not makes it true, so we've got true, true in an and statement, and remember from the last video, when they're both true, that's when the loop will be executed. The minute valid becomes false, which we're going to set it false, if we find a character, the loop stops executing. Or if we run all the way through the string and we get to the end of the string, then that's going to stop the loop executing and valid will be true. So we'll take a look at this. One more thing that we need is we need to know where we are in the string. So we're going to set the position of the string to 0. Remember, strings are 0 indexed, and every time through the loop we're going to add 1 to position so that we can look at the next character in the string. So there we go. I'm going to delete that stuff because we don't need it anymore, and now I've got to work on what goes on the inside of the loop. And it's very much the same thing, and it matches more what we did in the first one with the or rather than the and. We're checking for ones and zeros. So let's do it. So we need an if statement, and we're going to check if it's 1 or if it's 0. So if my binary string, now notice we didn't do it for each character in binary string, we've had to say it directly, and we have to say what position we're looking at. So the first one would be my binary string at the very first position. Imagine that's our binary string now. If that is equal to a 1, or my binary string at position is equal to a 0. So we've looked at the string and we've checked the very first position. Is it a 1 or is it a 0? And don't forget it's an if statement, so we need the colon at the end of it. If that is the case, if it is a 0, it's valid, and all we need to do is say, well, go and have a look at the next position. So what we do is we change position is whatever it was and add 1 to it. So for the next position, if we started off with 0, that would be 0 plus 1, which would be 1, and when position is 1, that would be 1 plus 1, so the next position would be 2, and so on through the entire string. However, we're now in that little area where we can keep adding them up and keep going along the string, but we could run off the end of the string and generate an error. So we're going to have to set this end of string, and I'm going to use a little bit of sort of programming magic. We haven't seen this before, but it's a way of setting something to true or false. See if we can follow along. So I'm going to set end of string is equal to, now in brackets I'm going to do a comparison, just as I do a comparison here with the double equal sign. That's a comparison. We're not assigning that value. Let me just take those spaces out. I'm going to do a comparison in here, and my comparison is if the position is equal to the string length. Now, we haven't set the string length at the moment. We're going to look at that in a second. But that is a comparison of two things. So 0, let's say the string length was 10. Ooh, I got a bit mad. Let's say the string length was 10. When my position is equal to 10, then I'm going to set end of string. So the only thing I need to do is work out how to set the string length. And we can do that before we enter the loop again by saying that string length is equal to the length len of my binary string. Don't put it inside the loop, that will change as or could change as we go along. So we've got these two conditions, and both of these two conditions need to change inside the loop. They both need to be true to go into the loop, into the while loop. They both need to be true, so we've set that there as true. We've set that as false because we are inverting it there, so both of these are true to go in. At some point inside the loop, we are going to say that valid changes or end of string changes. And we're going to print valid once we are out of the loop. So let's just have a little bit of a run of this program. Let's delete this, otherwise we'll get a mistake. Let's have a little bit of a run of this program and see where we've got any mistakes. So if I can just save, let's save that as 3A so I can keep my original one, and quickly run the program just to see if anything's working or not. Here we go. So please enter a binary string. I'm going to enter 1010 and it comes out as true, which is what I wanted. I'm going to enter an invalid string, so 1A10, and wow, as you can see, we've got a small problem. The program is continuing to run. It hasn't picked up what our error is. We'll deal with that in the next video because I'm aware that this is getting a bit too long.